In this machine learning class, we will see the logistic regression model from 4th unit, supervised learning. And here we will discuss the definition of logistic regression model, and we will see one example for this. After that, the list of assumptions in logistic regression model. Okay, let us see all those things one by one. Logistic regression. So in this logistic regression, the dependent variable y is the binary variable. Okay, that is, it has the value either 0 or 1. But the independent variable x is continuous numerical value. Right? See here in this diagram, this is x-axis. The value of x-axis is continuous value. And when come to y-axis, this start from 0 and end with 1. Okay, in between it is having some fractional values between zeros and 1. Okay, here if x and y have strong positive linear relationship, okay, x and y are strongly related to each other, and the probability of y, so what, the y value will reach to 1, which increases if the value of x increases. Okay, so if the x value is increased, then the probability of y equal to 1 will also be increased. Right? Okay, here the goal of logistic regression is to predict the likelihood that y equal to 1. That is, the probability that y equal to 1 rather than 0. Right? Which gives certain value of x. Here we are going to predict only the probability value, not the exact value of y. Right? So we are predicting the probability rather than the score of dependent variable. So the dependent variable is y. So we never consider about the exact value of y, but we are going to compute the probability of y, which is equal to 1. Okay, so this is logistic regression, and it is used in both classification as well as regression. Why it is used in classification? Because y value equal to either 0 or 1, right? And it is used for predicting the outcome of categorical dependent variable, similar to y-less regression. Okay, and next let us see an example for this logistic regression. Now predict a small project will succeed or failed. Okay, our problem is whether the project will succeed or failed on the basis of number of years of experience of project manager, okay, who is handling the project. So based on the experience of project manager, we can predict whether the project will be succeeded or failed. Okay, that is, the project manager who have been managing the projects for many years will be more likely to succeed. If he is having more experience, then the success rate will be high. Okay, that is, the x increases. X means the number of years of experience of project manager. So the project manager's experience is increases, then the probability that y will equal to 1. Okay, that is, the success of new project will get increased. Okay, so in this x-axis we are having experience of project manager. Okay, years of experience, for example 0 to 60 years of experience. Next, in y-axis the value should be 0 to 1, isn't it? So 0 and 1. If y value reaches 1 means the project gets succeeded. If it reaches 0 means the project is failed. Okay, that is exactly depend on the experience of project manager. For this problem, 60 already executed projects were studied. Okay, the training data set. This is training data set. Okay, so the years of project manager experience range from 0 to 20 years. Then increase the probability that y equal to 1 with the graph, right? So here the years of experience into categories. This is the training data set. X is given by the range of experience. Okay, project manager's experience, and the corresponding y value is given here. Okay, accordingly we try to plot the graph. Okay, so this is x-axis and this is y-axis. X-axis is number of years of experience and the probability of succeed, not the exact value of y. Okay, so here we are going to predict the probability of the target variable. So in this diagram, if the x value increases, then the probability that y equal to 1 will get increased. Okay, so from this graph we can understand that if x value is increased, then the regression line moves towards the 1 value, y equal to 1 value. Okay, it's moving upward direction only. So upward direction, the success rate will get increased. Okay, if the project manager has more years of experience, then the success rate of project will get increased. Right? Here, the perfect relationship represent the perfectly S curve. So this is not a straight line, isn't it? So this is not a straight line. This is S-like curve we will get because of this OLS regression. Okay, so the model, this relationship, we need some fancy algebra or mathematics to get this bend curve, that is the exact regression line, right? So to get that S-like curve, the logistic regression begins with the logistic function, which always takes the value between 0 and 1. Okay, so the log function will take the values between 0 to 1, isn't it? That is the output of log function. Hence this type of regression is called as logistic regression. Okay, so this formula state in terms of probability that y equal to 1. What is the probability for y equal to 1, which is referred to as p? P equal to y equal to 1. Then y equal to 0 means 1 minus p, isn't it? So here we are going to compute only the probability, right? So in that is log of p by 1 minus p, which is equal to a plus bx. A plus bx is nothing but y. Here the y value, expected y value is 1. Okay. Now log of p by 1 minus p, that is p by 1 minus p, which is equal to b0 plus b1x1 plus b2x2 etc. plus e. Okay, here the in is represented as the natural logarithm, that is log function, and a plus bx is the simple regression equation, isn't it? That we know very well. And the probability p, this probability p can also be computed from the regression equation. Okay. Our aim is to predict the probability that y equal to 1 for the given x value. So this is what our goal. So y equal to 1. What is the probability for that? So the probability of y equal to 1, which is equal to exponent of a plus bx divided by 1 plus exponent of a plus bx, which is equal to e power a plus bx divided by 1 plus e power a plus bx. So this is the formula. And exp is exponent function, which is sometimes also written as e, that we know very well. Okay. And now let us see another example for this logistic regression. Now we need to predict whether the person is male or female based on the given height. Okay. And the given height is 150 centimeter and a value is minus 100, b value equal to 0.6. So these are the values given in problem itself. So with these values we try to predict whether the person is male or female. Okay. And now what is the formula for our logistic regression? Y equal to e power a plus bx divided by 1 plus e power a plus bx. Isn't it? So this is what our problem. Now we try to substitute our values into the equation. So A value is minus 100, B value is 0.6 and X value is 150. X value is 150. So now we substitute all the values into our formula. Then we get y equal to 0.000046, which is approximately equal to 0. Right? That means, see, this is our graph. So in this graph, if y value is 0 means female and y value 1 means male. Okay. Now what is our y value, which is equal to almost equal to 0, isn't it? Nearby 0. Then the person is not male. The person is not male, hence the person is female. So this is what our result. And now let us see some of the assumptions in logistic regression. The first one is there exists a linear relationship between the logic function and the independent variable. Okay, that is the relationship between the logic function and the independent variable x should be very important. And the second one is the dependent variable y must be categorical. Okay, so binary value should be assigned for y. It may be either 0 or 1. For example, if it is pass, then y equal to 1. If it is fail, then y equal to 0. Okay, likewise, y accepts only the binary value. And third one is the data meets the independent and identically distributed criterion. That means the error terms are that independent and identically distributed. There is no dependency in the error in the data. And the error terms follows binomial distribution n comma p. Here n is nothing but the number of records in the data, that is training data set, and p is the probability of success rate, that is pass or fail or responder. And so far we have seen the logistic regression model from 4th unit supervised learning. In this class we have seen the definition of logistic regression model, and we have seen some of the examples also for understanding this regression model. After that, the assumptions in logistic regression. In the next class we will see the maximum likelihood estimation, which is the last topic of 4th unit supervised learning.